Thanks for tuning in to the Lean 911 podcast, where you'll have a voice directly from the Gemba. I will rely on my 3 decades of lean successes as well as my failures to answer your most challenging questions regarding your lean transformation. I'm your host, Mark DeLuzio, President and CEO of Lean Horizons Consulting and the Principal Architect of the Danaher Business System. Looking forward to your questions. Now, let's go to the Gemba. Hello again. Welcome to episode 8. We're going to talk about lean capital expenditures or capital acquisitions as it relates to equipment. And how do you think about that? You know, going back in time when we looked at how we used to justify capital expenditures, the finance guys, and I am a recovering finance guy, so I'm guilty as charged. We look at a couple of different measures, and nobody really understood what they meant, but one of them was net present value, or NPV, return on investment, ROI. Then came along economic value added. We had another different twist on the world, EVA. So we had all these different measures that we measured ourselves by in terms of capital. And one of the things we never did is went back to see whether or not that capital ever produced the results we said it would when it came to our capital acquisition process. But it really didn't matter, simply because all those numbers were hocus pocus anyway. When I became the chief financial officer for George Konensaker at Danaher's Jake Break in the late 80s, I took all of our capital acquisition requests for 1 year. And on each one, they had a box that was supposed to be filled out by all the, primarily people who bought capital, primarily engineers. And it was a box that said annualized savings. And I took all those CARs from 1 year, capital appropriation requests, we call them CARs, and I added them all up. And do you know that the savings that we documented as projected with this, these capital purchases was greater than our cost of sales? I mean, it was incredible. We were going to save so much money. I went back to Konensaker and I said, hey, why don't we just buy more equipment and forget about making Jake breaks, because we're saving so much darn money, right? And it was a joke, right? Now, in all fairness to the engineers and all the people that put those things together, our accounting systems were so flawed. We had the old standard, batch and queue cost accounting system with inflated overhead rates, and nobody ever knew what was in the numbers. So I can't blame them for trying to do their best at that, and they did try to do their best. But I'll talk more about this when we get into a segment in the podcast on lean accounting, because there's a lot to be said on that one. We'll probably have a multiple set of podcasts as it relates to that subject. But anyway, when you get down to capital expenditures, there's a lot of questions that have been asked over the course of time in terms of how to think about capital equipment. And I was lucky enough to have worked with Chihiro Nakao, who is the father of moonshine, and he created the 3P process, which very simply means production preparation process, and how to think about equipment from a true lean perspective. I also worked with him on developing the first 3P project in the United States on our Hino line at Jake Break. I was in charge of the Asian business, and also got to work with Hino Motors consistently with Nakao to develop this line. And it was by far not only the best line or cell, I should say, in Jake Break, it was the best one we had in Danaher. If you wanted to make a defect, you couldn't do it. So anyway, I was very fortunate to have that kind of mentorship with Nakao, and also some great Hino engineers. As you know, Hino is owned by mostly by Toyota. So we had a lot of that TPS influence there as well. So I'm going to take you through a couple of the key questions about CapEx and how to think about it from a more of a lean perspective. And that's what I'd like to take you through now. There's only a couple of questions I think I want to share, and I think these will cover the topic quite readily, I believe. Okay, so anyway, episode 8, lean from a CapEx from a lean perspective. One of the questions I get first is, well, how does one apply lean thinking to capital equipment decisions, right? And there's a lot to this subject. And one of the things that Nakao taught us was that, look, you and your competition can go out and buy the same materials. And if you go out and buy the same capital, you've got only a small margin to become extremely competitive. And you better do that through your design and have a better design, better quality, better service, better lead time. But when you take capital equipment and, you know, neutralize that amongst your competition, you eliminated a major source of competitive advantage. So his idea, and this is how he became the father of moonshine, was to develop your own equipment. But you're not just going to develop equipment to replicate what's out in the marketplace today. Oh, no, absolutely not. You're going to do all kinds of other things that will really, truly give you a lean competitive advantage. So you don't want to, uh, be a same as by buying the same equipment, but you want to build in things like one-touch changeovers. Is your equipment conducive to one-piece flow? Hanadashi, which means it's Japanese for unloading. Does it have Hanadashi devices? Does it, have one operation to machine? This is something that Nikao was really big on, and I'll talk about that in a minute. Is it simple to maintain? Is it really complex that you need high-skilled, technicians to run the darn equipment? Well, that's not any good, right? And he also maintained no battleships, but PT boats, small, nimble boats. That's his analogy. No battleships. Do not buy a battleship that does 500 different things. So let me give you an example. One of my clients, we set up a cell that had, I'm going to go back in my memory here and say it had 5 machines. Tack time was 2 minutes. And we had all the cycle times under tack time of these 5 machines. And we had the operator work sequences time to tack time. So basically, if you stood at the end of that cell, you would get a part off every 2 minutes. All right. That was great. Well, about 6 months later, I went back to the same client. And the first thing they said, Mark, you got to come down to the shop and see what we got going on down there. We got a new piece of equipment. And the first thing, the red lights went off in my mind. I said, okay, let's go see what happens here. They take me down. They replaced the 5 machines with a 2-minute tack time with this monstrous operation. And they said something like, well, geez, the 10 minutes of cycle time that cell had, we can now do this in 6 minutes. I go, wow, that's great. Did your tack time change? No, it's still around 2 minutes. Okay, well, how's your second and third shifts doing? How did you know we had to put a second and third shift on? It's because your tack time's 2 minutes. Your drop-off rate on this piece of equipment is 6. You bought a battleship. You bought a battleship with a drop-off rate 3 times higher than your tack time. So, of course, you're going to work 2 extra shifts. And also, you're probably working weekends, too, because you're not consistent on this thing. If this thing breaks, the whole thing goes down. And it was a bear to change over. Oh, yeah, our changeovers were really long. We got to work on that. None of this was considered when they bought this equipment. This was an engineer's dream to nirvana. Engineers love bells and whistles. They love all the lights and the fancy technology, and they reject things that are just, old. And I remember, Nakao-san told me, I was with him one time at one of our acquisitions, and an engineer came up to him and said, Nakao-san, we need a new machine. And Nakao, through the interpreter, said, well, why? Why do you need one? Because that machine is old. Nakao said, well, how old is that equipment? The engineer said, 15 years. So Nakao shook his head, and the engineer said, that sounds right. Nakao said to the engineer, how old are you? I'm 32. Nakao said, looks like we need a new engineer too. Okay. I mean, they hated when you went to them and told them that the equipment was too old, because it was like, well, if you maintain it, first of all, the first problem, right? The other thing is, when I was at Hino and I looked at the connecting rod line, I spent a whole day studying this line. And I foolishly asked the engineer, where do you put your defects? He said, Deluzio-san, we don't make defects in this cell. Okay. And the youngest piece of equipment in that line was 10 years old. Right. It was incredible. Right. So anyway, those are some of the principles you want to think about as you go through. Now, I always get this question, hey, how about a fully automated line? Wouldn't that be the greatest thing in the world? Yeah. Okay. Well, ask Elon Musk how that worked over his Fremont, California plant, which used to be the Numi plant. Ironically, he went in with all his robots, and it was a failure. It was a big failure. He was losing $15,000 per car, and that's despite the fact that the government was subsidizing him to the tune of billions of dollars. Right. So so that didn't work. Right. Fully automated. Go back to General Motors in the 80s when there's a book called Relevance Lost by, I believe it was Marianne Keller, how they invest billions of dollars in full lights out automation, and it was a big failure for them. And they lost the auto race to Toyota. That's one of the reasons they lost it. So think about four different things that automation does. First, it cycles and it does what it's supposed to do. So it's supposed to drill a hole. That's the cycle. It drills a hole. It's supposed to shave off, material. If it's supposed to cut a piece of wood, that's the purpose of the machine, right? Then you've got the unload of the part off the fixture. The loading of the part is the third step, and then transferring that part to the next operation. Those are the four fundamental steps of automation. The answer to this question is full automation the best solution? No. Now, what you want, and this is where Nicole taught us about chaco lines, which means in Japanese, load, is you obviously have an automatic cycle. So if you're drilling a hole into a piece of metal, okay, it's the auto cycle, not a problem. You don't want to do that manually. Unloading should be automatic with a Hanadashi because you don't have to be precise, and you can use gravity. But loading the part is problematic. And that's where he suggests, provided the part is, you can handle it, it's not too heavy or whatever, you do it manually. Because the loading of the part always has to be precise on the fixture. And sometimes it's really hard to automate that, right? And I know engineers will debate me on that and say, no, we got robots that can do this and all that. But robots bring in a whole nother set of complexity and problems, including flexibility, that is maybe a subject for another day. And then, of course, the transfer is the other problematic part of automation. So Nakao always contended that the loading and the transfer, step 3 and 4, are the most problematic. So what you want is an auto cycle, an auto unload with a Hanadashi, a manual load, and a manual transfer. That's a pure chaco line. Okay, so you've got all the other four iterations of this. You've got everything being manual to everything being automatic, and then everything in between, right? But what you want is auto cycle, auto unload. You want a manual load and a manual transfer. Okay, that's ideally what you're shooting for in a true chaco load line. All right. So I get that question all the time, and the answer for a lights out factory, never seen one. And if you find one, let me know. I'd love to see it. And then I'd love to look at the statistics in terms of how successful it really is. All right. But we keep pursuing this, whole notion of eliminating labor, where in many cases, labor is the smallest part of your cost. All right. And we're not focused on the things that really matter. So, okay. So, what criteria did I use when I evaluated a capital appropriation request? That was another question I get. Well, what did you look at? And there were a whole host of things I looked at. And by the way, I baked these into the capital appropriation request. So when somebody brought me a CAR when I was the CFO, they had to answer these questions, or so I would reject the capital appropriation request. First of all, I used the Socratic method. And the first question I asked is very basic. Why do you need a new machine? What's wrong with the existing equipment? And tell me about the Kaizens that you've done on the old machine. Kaizens can be done on equipment, just like it could be on anything else. So what happened? And again, I'm going to deviate for a minute and just tell you a quick story. Is that a supplier? They made springs for our Jake brake. It's a flat spring. And our volume went up drastically. We were, growing like crazy. And the president of the company was walking me around, and he showed me this piece of equipment that he said cost $350,000. It was a stamping machine, and it was being assembled by all of his technicians. Mark, that machine over there is going to be yours because your volumes went up by 30%, and we can't produce the volume on the old equipment. So I then in turn said, can you take me to the old equipment? I went over to the old equipment, and I noticed that the die, over 90% of the travel before the die actually hit the coil stock was cutting air. The die was cutting air. And it was a really quick operation, but nevertheless, I'd say 90+% based on my rough timing said that the only time that die added value was when that die hit the coil stock and it cut out a part. Okay. And then it went back up, came back down again. Okay. So he had 90% waste in that process. So I asked him, I said, you think you can bring that die closer and or speed it up? And he said, geez, I don't know. Let's get some engineers over here. So they came over and they looked at this and they said, yeah, we could probably do it. It might cost a couple of thousand in this, tooling, whatever. I said, geez, if you had spent a couple $1,000 and talked to your engineers, you could have Kaizen this equipment and saved $350,000 of capital. And the guy turned red in the face. He goes, oh my God, I can't believe you. And I'm not even an engineer, guys. Okay. And I saw this. Right. So the notion to go out and just spend money on capital needs to be kind of held in check. All right. The other question I ask, what's the takt time? What is the takt time on the process that's going to be used on? What's the demand on that equipment? Not only today, but what about a year from today, 2 years from today? Is this equipment going to be able to handle a growth spurt? Okay. Or are you going to hit a point where you're going to have to go out and buy another increment of capital? And that's exactly, by the way, what the capital equipment makers want you to do. They don't want you to, have small increments of capital where your investment is minimized, right? So what's the takt time? If you're buying a machine like the example I gave you that has a 6-minute cycle time and you have a 2-minute takt time, that's not a good thing. And I will hold that most of the time when you go to a second or third shift, it's because you have equipment capacity issues. Other than that, you can handle everything else with labor, right? In terms of how you man the labor with work sequences to takt time. Okay. It's usually your equipment that drives you to a second shift. Show me your process capacity analysis, one of the 5 documents of standard work. I want to see a pro forma process capacity analysis, and that will answer the question I just asked about takt time. I want to see that as part of the CAR, and I want to see it for today's volume, and I want to see it for the volume a year from today. Okay, are we buying a bottleneck? I don't want that. What's the changeover time for the newer equipment? That's the other question I would ask. Does this thing have extremely long changeovers? Again, capital equipment manufacturers and salespeople want you to have long changeovers because they want you to put that order in for that next piece of equipment. So no, I don't want long changeover. Matter of fact, I don't want any changeover. I want one touch changeover. So how are we thinking about changeover when we look at this equipment? How will you assure quality? And I'm not talking about checking quality. I'm talking about assuring quality. There's a big difference between quality assurance and quality control. Quality control is an after fact. I inspected it. I looked at it, made sure everything's right. Assuring means I can't make a bad part. That Hino line I talked to you about had so many Pokeyoke and Jidoka devices in it. I mean, I don't think I could have made a bad part even if I tried. That's how good it was. And our Hino line was the same way. We had 100% quality to Mitsubishi and to Hino Motors from Bloomfield, Connecticut. Okay. And that goes right into what's the CPK of the new equipment? What about the data on that? Right. And what technical capabilities are you going to require to run the equipment? A lot of people justify this equipment because, hey, we're going to eliminate, 8 operators, but I'm going to hire 2 high-priced technicians and engineers to run the darn thing. No, that's not what we want. And then what about the maintenance? What about the whole maintenance side of this thing? How easy is it to maintain? Do I need special maintenance skills now that I don't have today in order to be able to do this, right? So those are some of the questions I would ask. And believe it or not, when you ask these questions, I eliminated a lot of capital expenditures simply because they were ill-equipped to meet our lean principles, right? So those are some of the questions that we had. I think when you think about lean in the context of capital equipment, you're not going to buy a solution. Long term, your company is going to need to get to a point where you are going to have to build your own equipment, small, one operation pieces of equipment, not a piece of equipment that does 10 things all in one. That's not conducive to flow. That's not conducive to good quality. It's not conducive to any kind of expansion when it comes to, building your business and growing your business in terms of tack time. And you can actually get a competitive advantage by building your own equipment, making it proprietary, and not buying what everybody else is doing out there today. Okay. So that's the 3P thing. I'm sure we're going to have a podcast on 3P down the line to talk more about what that's all about. It doesn't only have to do with equipment design, it has to do with product design, and they go hand in hand, right? I think when you look at Toyota's brilliance in manufacturing, you can't help but think about how that was thought about in the whole design process itself. So there's capital appropriations. I thought hopefully I'd give you a little bit of perspective about how to think about this. Now you say to yourself, well, geez, what about the dollars? What about the cost justification, right? Yeah, you still look at that, of course, okay, but you've got to be very careful with what you use to justify something in terms of cost, right? In terms of return, in terms of what you're going to do. All these other things are equally important. As a matter of fact, I always hold that if you do the right thing in quality, safety, quality, and you do the right thing in lead time and delivery, which means that more frequent batches, more changeovers are necessary in order for you to reduce your lead time. And if you're not thinking that way, you got to start thinking that way, because cost will take care of itself if you could do those things. But if you're going to go out and buy a battleship, good luck with turning a battleship around. It will take forever. You could turn a PT boat around 100 times before a battleship turns around. And anybody out there from the Navy will probably vouch for my my saying on that. Anyway, so there you have it. Episode 8, CapEx. Hope this is helpful. Be sure to email me at mark@lean911.com with your questions, with your comments. And if we have to pick this up again down the line with further thoughts on capital equipment, we'll be more than happy to do so. Thanks. See you next time. Bye-bye. Thanks for listening to the Lean 911 podcast. I'll be happy to address your questions or feedback on future episodes. Email me at mark@lean911.com. You can check out our other episodes by visiting our website at lean911.com, our YouTube channel, wherever you listen to podcasts. This is your host, Mark DeLuzio. Thanks for listening.